One of the unique and distinctive attributes of the Geosciences at Union College is the way in which we integrate engineering into the curriculum.
Engineering is a very important part of the Geosciences. Engineering doesn't operate in a vacuum. Engineering has relationship with almost every aspect of our daily lives, whether it's the clean water that we drink or the clean air that we like to breathe.
And what this means for the average student is that you can take courses at Union in the Geosciences that are taught by engineers. These include courses for both the geological sciences and also environmental science that are focused on hydrology, wastewater, waste management, green buildings, and a number of other important courses. So often we find that our students who graduate and go out to the workforce will end up in consulting firms, and in those cases they need to be able to understand engineering and they need to be able to communicate with engineers.
My project that I did was developing pervious rubberized concrete, which is an environmental form of concrete.
The beauty of this material is it is pervious, which means it allows the water to percolate through. When you allow this to happen, the water recharges the aquifer and you basically renew the hydrological cycle of water much faster.
When constructing parking lots out of it, you don't need to worry about adding drainage accessories. What I mean by this is you don't need to slope the parking lots or add gutters because water is simply going to go right through it.
It's a material that will help the destruction of harmful oil particles before they reach the underground water. And on top of all this, it's a material that doesn't retain heat, therefore it makes it easy to conserve energy in fossil fuel that probably would be used in air conditioning.
It contains waste tires in it. So normally tires are thrown in landfills, and there's currently billions of tires in these landfills, and millions are added every year. And these landfills are really bad for many reasons. They're a breeding ground for mosquitoes and rodents because water gets stored in the tires. Also, to dispose of the tires, the primary way to do it right now is to burn the tires, and that will leak toxins into the air and will also leave residue behind on the ground, which is very bad for the environment. So finding a way to dispose of these tires is very important. So putting them in concrete is just a very good thing.
In the lab, we developed a number of mixtures, all of which were tested in compression, and they were also subjected to water flow to study the permeability through the material.
We tried to vary the amount of rocks, rubber, sand, cement, and water that would be put into these mixtures, and we were trying to find the optimum ratio to use.
There are so many variables, there are so many parameters that affect the design, and we have to vary all these parameters until we come up with a mix that serves the purpose that we have in mind.
You want to incorporate lots of rubber to dispose of the tires, but you also want to have lots of coarse aggregate or the rocks, which makes it more pervious. So the more rubber you have, it's going to be more durable but less strong, and the more fine aggregate, which is the sand that goes into it, will increase the strength but will decrease the permeability.
The application we had in mind was a simple sidewalk, and we wanted to pave an area here at Union College with this pervious rubberized concrete. So we tried to develop a mix that would be good for a sidewalk and at the same time pervious and contain some percentage of rubber.
We didn't settle on the best mixture at that point, so we decided to use 3 different mixtures to help us determine what we thought would be the best mixture to use.
Every one of which with a certain percentage of rubber and certain percentage of sand. We maintained the weight of coarse aggregate, which is basically crushed stone, constant, and we maintained the weight of cement and water also constant, and we varied the rubber content and sand content.
This summer, on July 3rd, we finally were able to pave it.
We basically observe the performance of the concrete every time there is a rainstorm, and so far it has been performing the function it was designed for, the way we like it to be.